Hi everybody, welcome to this video. After discussing median and mode in the previous two ones, let's now discuss the last measure of central tendency, the mean value. The mean is what most people think of as the average. You can think of it as the total amount being shared out equally between across all the participants in a certain situation. But one important limitation is that mean can be strongly affected by outliers. That is, extremely large or extremely small values. Here's an example using salaries. Our data set includes one unusually large value of £1 million. When we arrange the salaries, the median or the middle value is just £35. But if we calculate the mean, we have to add up all the values and divide the sum total by the total number of salaries. And once we do that, the average jumps to £142,885 and 57 pence. Now, this huge difference shows how sensitive the mean is to extreme values. Unlike the median, which reflects perhaps the situation with most of the people. For those who still don't understand how the formula was written out, in the formula, the x with the subscript I means each individual data point. So to make it even more obvious, I've also put up a table of data points. So whatever data was written as one set is now tabulated as in two columns. So xi means any individual value of x, and the Greek symbol sigma means the sum of all individual values. And because there are 7 data points, so I've written out 7 x variables. So x1 represents the first value and x7 represents the last value, and we have just added all of them because the sigma, the Greek letter sigma, means you add all those values. And this is how we calculate the mean. So in the last example, every data point appeared just once. What if the data points repeat? Is there a quicker way of computing means? For example, 30 students were asked as to how many instruments they can play. Some said 1, others said 2, 3, 4, or one talented individual even could play 5 instruments. So these answers are repeated. The most common answer, as you can see in the second column of this table, was 1, because one instrument, the answer 1 was repeated 11 times, as you can see in the frequency row for this. Similarly, 10 students said that they could play 2 instruments. And similarly, the answer 3 was repeated 5 times, the answer 4 was repeated 3 times, and the answer 5 was given only once. So we can call these counts as frequency of the data, and the table represents the frequency distribution that we have seen in an earlier video. Now, if we compute a mean in the old-fashioned way, we must add all the answers. That means add 1 11 times. So I couldn't write it 11 times, so I just put the 3 dots there to include, just to show that we are adding ones more and more. Similarly, 2 was added 10 times, so I've just added 2 plus 2 and then 3 dots to show going up to another 2. And 3 was added 5 times, 4 was added 3 times, and 5 was added just once. But wait a minute, why can't we write it more compactly? So I said add 1 11 times. So if that is the case, I can rewrite it as 1 times 11 plus 2 times 10 plus 3 times 5 plus 4 times 3, and finally 5 times 1. And we divide it by the total number of data points, which is the sum of all the frequencies put together. Essentially, we multiplied each x, which appears in the first row of the table, with its frequency f, which appears in the second row of the table, And then we divide by the sum total of the frequencies. So essentially we are averaging the result. And so we get the mean value of 2.1. So we can generally write the formula to compute the mean of a frequency distribution as mean mu is equal to sum of each frequency multiplied by the corresponding data point divided by the sum of frequencies. So sigma fx over sigma f. You can pause the video here if you want and go over it slowly if you need to. So here's the same example rewritten for you. Here's the same frequency distribution, only the table is given in 2 columns this time around, but otherwise it is identical. Then we add in an extra column that multiplies each x with its corresponding f. And at the bottom we add the last 2 columns. And then we compute the mean value as before. So this is another way of doing it. And again, you can pause the video and understand it if you want to. Suppose we are now given ranges of values and their frequencies. This is common in continuous data where exact values cannot be measured. Refer back to the earlier video on continuous data if you don't know what we mean. For example, here are lengths measured and they are given as groups or intervals. So the first length group is from 4 to 8 centimeter, and this group is represented twice. So this is why its f value is 2 in the first row. 9 to 13 appears 4 times, 14 to 18 appears 7 times, and so on. So what is the mean value? Well, to compute that, we must know the frequencies f, which we are given in the second column. But what about x? In place of x, we have a range or interval. So what do? So the rule of thumb is we choose the midpoint of each interval as the representative value of that interval. This we compute by averaging the lower end and the upper end of each interval. This is shown in the second column. So you can pause and just work each average if you want to. So once we have computed the midpoints, we ignore the first column and work out the mean as before. So we use the totals at the bottom row of the table to compute the mean. And it turns out to be 20.6. We are given the result to 1 decimal place. So again, if you are not sure, you can pause the video here and work it out manually.